Okay, so I'm going to continue where we left off. Today we're going to talk about expressions, which is probably going to be like the most difficult section, I suppose. It's just really just introducing you to like what you can do with variables. So you're going to learn how to like multiply, add, divide, things like that. And then we'll talk about data conversions, which is basically converting from one type to the other. And then interactive programs. I've already introduced that to you, but we're going to go over the slides again. And there's a few things I need to show to you about interactive programs. And then when we're done, I'm going to give you guys a quiz. If you don't have time to finish the quiz in class, then you can just take it home, but get it in Dropbox by midnight. Okay? All right, so expressions. An expression is a combination of one or more operators and operands. Arithmetic expressions compute numeric results and make use of the arithmetic operators. So you have addition, you have subtraction, you have multiplication, division, and then you have remainder. Is anybody familiar with the remainder one from other programming languages? Like, no? All right. So what the remainder one actually does is it just, if you put it between two numbers, it's going to divide them, but it's going to give you what is left over and not the result of the division, if that makes sense, right? So like if you divide 10 by 4, okay, then like 4 goes into 10 two times, right? And then you have 2 left over. So the result of 10 divided by 4 using the remainder would give you 2. Like that would be what you get out, okay? All right, if both operands to the division operator are integers, the result is an integer. The fraction part is discarded. Okay, so that's important to know. So 14 divided by 3 is going to equal 4 because 3 goes into 14 4 times, 12. But integers do not retain the fraction part, right? So 14 divided by 3 as integer is always 4. Likewise, 8 divided by 12. Okay, so that is a fraction, right? 8 divided by 12. The result of that with integers is going to be 0. Okay, so using integers will have some unintended consequences. If you're trying to do like precision type math where you want to retain a fractional part, so keep that in mind. The remainder operator returns the remainder after dividing the first operand by the second operand. So 4 divided by 3 using the remainder operator equals 2 because 3 goes into 14 4 times, which is 12, and you have 2 left over. Okay, here's an interesting one. Using the remainder operator, when you divide 8 by 12, the result is 8 because 12 doesn't go into 8 at all, so you have 8 left over. Right, does it make sense? Like that's what you get as the result of writing 8 remainder 12. You would get 8 because 12 doesn't go into 8 at all. Okay, so here's like a quick check. Okay, so if it doesn't have a decimal point, then it is an integer. If it does have a decimal point, then it is a double. Remember we talked about that the last class? So if you divide 12 by 2, what would our result be? 6, right? How about 12 by 2 with, like, they're both doubles, what would our result be? Yeah, 6.0. The 0 would be there. 10 divided by 4, 2. Okay, 10 divided by 4, but 4 is a double, but 10 is an integer. That's interesting. It would convert. So Java does what we call like up converting. So whatever the bigger one is, it's going to convert the math to that. So 10 divided by 4 as a double, it would, since you're using a double, it's going to retain the decimal place. So you're going to get 2.5. Or is it 2.5? Yeah, 2.5. Okay. 4 divided by 10, both integers? 0. Okay, good. Then 4 divided by 10, where the 4 is a double and the 10 is an integer. No, because it's treating it like a double now, right? So it's going to be 0.4, right? Okay. All right, and then you have 12 remainder 3, right? 0 because 3 goes into 12 an even number of times, right? It goes in 4. You have nothing left over, so it's 0. 10 remainder 3. Okay, that would be at 1 because 3 goes into 10 3 times, right? And that's 9, so you have 1 left over. and then 3, remainder 10. It would be 3, right? Because 10 doesn't go into 3 at all. So you have 3 left. And here are the results. Wait, 0. Why did I put 0? Doesn't make sense to me.
You didn't write these PowerPoints, did you?
No, I didn't. But I'm wondering, like, is something fishy going on? Like, why would they write that? So, seems like there's a mistake. Let me just verify that. So I'm gonna go ahead and just type this up really quick. Instead of using TextPad, I'm gonna use Notepad++. I wanna keep my computer guessing. Change things up. All right, I'm gonna make a quick demo. And I'm gonna put this into Dropbox. Let's see, so. Under demos, chapter 2, I'll call it remainder demo. Okay, so remainder demo, and I'm going to save my file as a Java file. All right, public class, remainder demo. And then public static void main string array arguments. All right, so I'm just gonna make an integer for num1, and I'm gonna say this is 3, and then I'm gonna make an integer for num2, and I'm gonna say this is 10, and then I'm gonna make an integer called like remainder, and that is going to equal to num1, which is the smaller number, remainder num2. Okay, so it's basically saying divide 3 by 10 and give me whatever the remainder is, and I'm going to do a system.out.println. All right, save. And I don't have Notepad++ set up, so I actually have to use command prompt to run this. So I'm going to change directory to Dropbox, public, NVC, oops. Java shared content, yeah. Demos, chapter 2. Okay, and then I'm going to say JavaC, remainder demo dot Java to compile. Wait patiently, it compiles. So Java remainder demo to run. Okay, so the result is 3. So I wonder if I might have accidentally changed that. I don't know. That seems like an obvious one. All right, so it's 3 because 10 did not go into 3 at all, so you have 3 left over, right? Makes perfect sense. It would make completely no sense if the answer was 0. Like I would have been, like I wouldn't know, like I would just be confused. Everything I've learned has been a lie. Okay, so operator precedence. So the way that math works, right? Where you have like those mnemonics where you say, what is it? Please excuse my dear Aunt Sally, right? You guys remember that? Where you do parenthesis math first, right? And then multiplication, division. And then, actually take that back. I guess exponents would be before multiplication, division. And then multiplication, division. But the interesting part that everybody gets confused is that multiplication, division actually occurs at the same time from left to right. So if there's division before multiplication in that line of operators that you're working on, the division actually comes first. And then addition and subtraction as it occurs from left to right. Okay. Operators can be combined together into larger expressions. So here they're saying result is equal to total plus count divided by max minus offset. So if you're following the order of operations, what's highlighted would actually occur first, right? And then the addition subtraction would occur like in order from left to right. Operators have a well-defined precedence which determines the order in which they are evaluated. Multiplication, division, and remainder are evaluated, okay, before addition, subtraction, and string concatenation. So multiplication, division, remainder all have precedence. Arithmetic operators with the same precedence are evaluated from left to right, but parentheses can be used to force evaluation order. So if you use parentheses, then you can use that to force evaluation order. Okay, then here they're giving you a quick check. First one's pretty simple. Okay, so here they want you to number which one's going to happen first. So since it's all multiplication, excuse me, not multiplication, since it's all addition, it's going to happen from left to right. So it's just going to happen in order from left to right, right? So it's just going to sum all these up together. Over here, it's a little, oops, I didn't mean to move that. Over here, it's a little different, right? Because we have multiplication, we have addition, subtraction, division, all happening in the same line. So what's going to happen is the B and C is going to be multiplied first because that is it's going from left to right, so that's most left, right? And then the D divided by the E is going to happen second. And then it's going to go back to the front and do addition, subtraction. So then you're going to add, and then you're going to do the subtraction. Okay, this next one, let's look at this. All right, the first thing that's going to happen, can anybody tell me? Right, because that's in parentheses, so you're forcing that order. So B plus C is going to happen first, and then it's going to go to the front of the line and go left to right doing multiplication, division, and remainder. I keep forgetting to throw a remainder in there because that is the same thing as doing division. So you're going to do the A divided by whatever the result is of B plus C, and then you're going to do D remainder E, get that result, and then you're going to subtract the two. Okay, the next one, since you have nested parentheses, you're going to do the innermost parenthesis, then the next outer one, then the next outer one, and the last thing you're going to do is the A divided by whatever the result is. It does take precedence, right? But parentheses are going to happen first, right? And then remainder and division are considered to be like at the same level. So that's going to happen in order in which they appear from left to right. So, right, yeah. All right, and then here are the results. Okay, so the one we just talked about, right? The parentheses happen first, then the division, then the remainder, and then you have the subtraction you've done last. The first one was obvious, I thought. The second was also obvious because we didn't like do anything quirky in there. We just added, multiplied, subtracted, divided. And then this last one where we had the nested parentheses, the innermost parentheses happened first. Expression trees. Okay, I'm not going to require you guys to do expression trees or anything like that, but I guess it is something good to know, like if you're trying to figure out what's going to happen first. Okay, the evaluation of a particular expression can be shown using an expression tree. The operators lower in the tree have higher precedence for that expression. Okay, so they're saying here is the equation. So B minus C is the first thing we're going to do. So it's going to be lower, right? And then we're going to subtract B minus C. Excuse me. The result of subtracting B minus C is going to be divided by D because that's the next thing that's going to happen. And then the last thing is that result is going to be added to A. Okay, so that's an expression tree. The assignment operator has lower precedence than the arithmetic operators. So basically what's going to happen is everything to the right of the assignment operator is going to happen before you actually assign that value to the variable. Okay, so what they're saying is all this is going to happen before the assignment gets applied to the variable assignment. All right, it's almost like wrapping it with parentheses. Okay, so you're not gonna like take sum and then assign it to answer and then do the division and then add and all that. Like everything on the right side is going to occur first. Okay. The right and left sides of an assignment statement can contain the same variable. Okay, so here's something a little interesting. You have count is equal to count plus 1. Can anybody tell me what that actually does if we do write something like that? Right, it's taking whatever value that you have already inside of count. Let's just say you had 7 inside of count, okay? then when you get to this line, you're basically saying, you know what, I'm going to take 7, whatever's in count, add 1 to it, and then I'm going to reassign that back into count. So now after this line is complete, count would be 8 because you just took whatever value it had and you added 1 to that. Okay, instead of doing something like this where you just add 1 to it, adding and subtracting 1 to a variable is something that is actually done a lot in programming, especially when you're iterating through like a collection set. Right? All right, and we'll actually talk about that by the end of the class, or not this class, but the end of the course when we get into chapters 5 and 6. So we have an operator for incrementation and decrementing as well. So we have a statement count plus plus that essentially is the equivalent to count is equal to itself plus 1. Okay, same thing with count minus minus. It's the same thing as count is equal to count minus 1. Okay, so there is something that you need to know about the incrementing and decrementing is when it actually takes effect. So incrementing and decrementing operators can be applied in post or prefix form. So you can put the plus plus at the end, or you can put the plus plus at the beginning. Does anybody know like what different effect would actually occur when you do something like that? Like what does putting the plus plus at the end do? Name it. I'm sorry, what's that? I mean, it's going to increment it by 1, right? Like both of them are going to increment it by 1. But putting it at the end is like telling Java, don't increment that value until that line is complete. Okay? And putting it in the beginning is telling Java, increment count like at that moment, right? It's like putting it in parentheses, like it has priority. You want to do it right when that value is used. Okay, so when used as part of a larger expression, the two forms can have different effects. Because of their subtleties, the increment and the decrement operators should be used with care. I need to demonstrate that to you before I move on. All right, I'm going to come over here and I'm going to make a new file. And I'm going to save it as, I think I did this for, oh yeah, there it is right there. Like I made a video for the online class. I'm going to say increment, decrement, example 2.
So having the plus plus at the end would do it at the end of the end of the operation on that line.
So having the plus plus at the end will make that value for that variable take effect on the very next line. So it basically happens at the end. When everything's done, executed on that line, even the assignment, then the value is increased. All right, so let me just type up a quick example. So I'm gonna say public class increment decrement example 2. I'm gonna create my method header, public static void main string array. Wait, did I start recording? Dang it, I hope I did. Okay, I did. For a split second, I was like, did I start that? Like, I don't remember if I did. Okay, so I'm going to say arguments get passed in, open, close, curly braces. Okay, so I'm going to make a value. Let me see. I'm going to make an int. I'll call it, I guess I'm so generic with everything, but I'll just say like num1. We'll just say num1 is 7. Oops, that's not the way you would do that. Num1 is 7. And num2 is 50. Okay, so I'm going to say system.out.println. I'm going to like print out the values for these. Save that, and I'm going to go over here to compile really quick. Dang it. Since I have another one named almost exactly the same, it's going to be a pain in the butt. All right, compile, and then run. All right, so I mean, the result as is what we expected. Okay, so now what I'm going to do is I'm going to say num1 plus plus, and then I'm going to say num2 minus minus. Oops, that's not minus minus, minus minus. Okay, and then I'm going to print out my results. And I'm going to go ahead and just put like a new line right there, so it's on there's space in the console when it's printed out. Save that, hop back over here, compile, run, and you can see that I incremented num1, so now it's 8, and I decremented num2, so now it's 49. Okay, so now when I do the exact same thing, but I put the plus plus in front and the minus minus in front, you're going to see that it appears that it actually did absolutely nothing. So when I come back over here, compile, and I run, okay, it incremented it and decremented like appropriately, right? It did the exact same thing, like nothing was weird about what we expected, okay? But now let's do something to where we use those values. Okay, so let me think about this. Actually, I'll just do another print line, but this time I'll do it inline. I'm going to say num1, I put the plus plus in front, plus plus, and num2 minus minus. So I put the plus plus there, and the minus minus here, and I'm going to hop back over here, compile, and run. Okay, so at the very bottom, like right before I executed this line, num1 was 9, it went to 10. Num2 was 48, it went to 47, right? Makes perfect sense because I incremented one and decremented the other. Okay, now when I try to do the exact same example, here you will see that things are going to be just a little different. All right, I'm going to save that, hop back over to my console. I'm going to clear the screen, and then I'm going to compile and run. Okay, so it looks like, okay, so this took effect as expected, but then when I did it again, this time I did the post, it looks like it had no effect at all, right? Does everybody agree with that? Okay, and the reason why is because the value of num1 and num2 do not change until this statement is complete, right? So num1 doesn't change until that statement is complete. Num2 doesn't change until that statement is complete. And to verify that this is the case, I'm going to print out just one more time without incrementing or decrementing what the values are, and then you'll see on the last print, like the last time I print them out, the values would be what we expect. Okay, so here is where I did the post, right? But then on the very next line is where we actually see the result of what we did. Okay, so it's important to remember that in the post, that value doesn't actually take effect until that line is complete. Okay, so on your midterm, I'm going to trick you, like I'm going to just throw that in everywhere. I'm going to ask you, give me this following code snippet, like what's the value of some variable? And there's going to be one with the plus plus in there. And most students, or I don't want to say most students, but a few students will just think like that value gets changed like in place, right? So they'll actually end up with the wrong answer because they weren't thinking that when you use the post, the value doesn't actually take effect until the very next line. Okay, so you got to keep that in mind. Yeah. Any questions on that? Okay, yes.
So at the end means it takes effect on the next one. At the beginning means it takes effect on that one.
Exactly. So it takes place at that very moment. So it has like, it's almost like it has parentheses wrapped around it to where if you're actually using it in a math equation, that value is going to change like before it gets used in any other operator. All right, hopping back over here, assignment operators. So we often perform an operation on a variable and then store the result back into the variable. Java provides assignment operators to simplify the process. So you can write num plus equals count instead of writing num equals itself plus count. Okay, you can do that actually not just for addition, but you can do it for all the operators. So here they give you an example. If you were to write x is equal to x plus y, you can rewrite it like this, x plus equals y, right? If you wanted to write x is equal to itself minus y, you can write it like this right here, and so on and so on, okay? The right side of the assignment operator can be a complex expression. The entire right-hand expression is evaluated first, then the result is combined with the original variable. Therefore, result of divide equals total minus min remainder num is the same thing as writing result equals itself divided by, or divide, and then this result with the parentheses. Okay, so when you have something like this, where you're doing the operator with the assignment operator, it's like wrapping all this in a parenthesis. So you're doing all that first, and then you're going to do the division or the addition or multiplication, like whatever operator you're using. Make sense? Right? The behavior of some assignment operators depends on the types of the operands. If the operands to the plus equals operator are strings, the assignment operator performs string concatenation. The behavior of the assignment operator plus equals is always consistent with the behavior of the corresponding operator. Okay, so what they're saying is you can use plus equals on string for string concatenation, like if you wanted to add something to a string, or you can use it on numbers. Okay, so the plus equals can be used on strings or primitive data types that are numbers. Any questions on that? Okay, so the next topic is data conversion. We kind of already covered part of this. I'm just going to kind of read through the slides. There are going to be some questions from this section on your midterm. So just kind of, I mean, it's not too long. It's pretty short. But the most important one is knowing when to cast, right? So I'll just read the slides. But basically, there's two types of conversions. Either you're going narrow or you're going wide, okay? And we'll talk about both of them in data conversions. So sometimes it is convenient to convert data from one type to another. For example, in a particular situation, we may want to treat an integer as a floating point value. These conversions do not change the type of the variable or the value that is stored in it. They only convert a value as part of the computation. Widening conversions are the safest because they tend to go from a small data type to a larger one, such as a short to an int. Narrowing conversions can lose information because they tend to go from a larger data type to a smaller one, such as converting an int to a short. In Java, data conversions can occur three ways. Assignment conversions, which we already seen when we did that example or the quick check, where one number was an integer and the other number was a double, right? And the result of those two was a double. So that is like an example of data conversions. So there's three ways of data conversions. There's the assignment conversion, the promotion, and the casting. So here are examples of the different, for widening and narrowing. If you have a byte, then a byte, you can go to any of these, fine, right? It's just a table. It all makes sense if you know the size of each. A short can go to any of these, just fine. Char, any of these. Int, any of those. Long, any of those. Float, just that, right? But to go narrow, a byte can go to a char, a short can go to a byte or char, a char can go to a byte or short, int can go to a byte, short, or char, long, byte, short, char, int, float, byte, short, char, int, long, so on, right? Narrowing is the dangerous one, right? Because you're going from a larger data type to what is considered to be a smaller one. So you have to be careful with that. Assignment conversions occur when a value of one type is assigned to a variable of another. Example, Here we have int dollars is 20, so this value is an integer, but then you assign whatever value stored in dollars to double money. So now that value is stored as a 64-bit double inside of the variable money. That's an assignment conversion. Oh shoot, what the heck? I don't know what I just did. Okay, sorry about that. That is a assignment conversion. So only widening conversions can happen via assignment. Note that the value or the type of dollars did not change. Okay, so they're basically saying that dollars is still an integer and it still has 20 inside of it. All we did is just took whatever value that we had in dollars and assigned it to the variable money, which is a double. Promotion, this is kind of like this is what we did in the quick check when we had an integer and a double. Promotion happens automatically when operators and expressions convert their operands. So int count is 12, double sum is 490.27, double result is equal to sum divided by count. So sum is a double, count is an integer. The result of this math would be done in double. You won't lose any precision. So this has got promoted, the count got promoted to a double just for this math, and the result was stored inside of result. The value of count is converted to a floating point value. By floating point, they mean has a decimal point, not necessarily a float. A floating point value to perform the division calculation. All right, makes sense, right? Nothing like too strange yet. Okay, casting this is where we get like a little more, we do things a little differently. Casting is powerful and dangerous technique for conversion. Both widening and narrowing conversions can be accomplished by explicitly casting a value. To cast, the type is put into parentheses in front of the value being converted. So if you have int total is 50, then float result is equal to total divided by 6, and you're casting one to a float. Without the cast, the fractional part of the answer would be lost. So let me just do a quick example of that. Okay, so I'm going to hop back over here and make a new file. I'm going to save this as casting. I already did the casting example. Oh, it's probably for the online class. All right. Say casting example 2. And save it as a Java file. Save. All right, so I'm going to say public class casting example 2, open close curly braces, come in here and write my main method header, public static void main string array arguments, open close curly braces. Okay, so let me think of what I'm going to do. Totally don't know what. Okay, we'll just do like an average, right? So, yeah. First thing coming to my mind is like doing like a program that does, I think I did the exact same problem for the online class when I posted a YouTube video on this. I'm gonna go ahead and just do it as well. So I'm gonna say Java util.scanner. Make my scanner object. So I'm gonna say scanner scan is equal to new scanner. Listen to the keyboard. Okay, I'm going to make an integer for, let me see, I'm going to average 3 numbers. So I'm going to just say like num1, num2, num3. And then I'm going to make a constant. I'm going to say final int num of numbers. I know that seems weird, but that's what I'm doing here. All right. Yeah. Okay. So then I'm going to say something like system.out.print. I want to say enter num1. Okay, he's going to give me a number. I'm going to do this 3 times for 3 numbers, so I'm just going to copy and paste what I did. Oops, I left off the semicolon. So I'm going to say num1 is equal to scan.next int. Okay, we'll do it there. There. Okay, and I need to convert this from num1 to num2, num3. And then I'll say something like system.out.println. Say the average of, and then I'm going to do something like, I'm just going to put a placeholder here just so I know I have to go in there and concatenate in the value, value 1, value 2, and value 3 is, and then I'm going to print out the average. Okay, so I'm going to come right here, placeholder for num1, oops, should be num3. Come right here, placeholder for num2. All right, and I'm going to move this over, tab it over, and then I'm going to say the average. Okay, average. I don't have an average variable yet, so I'm going to just copy this right here, and I'm going to paste it right there. All right, and then right here, I'm going to say average is equal to the sum of the three numbers, num1 plus num2 plus num3. I'm going to divide it by num of numbers, I guess. I mean, I wish I had a better name for that. Sorry. All right, and I'm going to go ahead and compile and run this really quick. So the name of this, let me clear the screen. So the name of this file was casting example 2. Dang it, what the heck? Oh, I'm missing something. And close. Oh, right here. I didn't concatenate that in, right? I didn't yeah.
Is there an IDE that tells you what you did wrong?
There is, like IDEs like IntelliJ and Eclipse. Like as you're typing and make like a mistake like that, it will just put like a red squiggly line, like, "Hey, you made a mistake there." Yeah. So I know like that error was like super confusing. It just didn't really know what to do, right? Like. But if you look, it did show me, it gave me a hint. If I would have looked at my very first error, it would have given me a hint like saying, hey, you have this variable and you didn't like put any operator between that and the string, right? But then it gave me all this other stuff after it because it was still confused, right? But there's only one error, but it showed me that I had 3, right? The only mistake that I made was I didn't put in that plus sign right there. At least that's the only mistake I think I made. Let's see what happens when I compile. Dang it. Okay, so, I didn't initialize it to anything. Yeah, duh. Okay, I'm gonna make this 3. There you go. Okay, so I'm gonna go ahead and run this. Okay, it's asking me for 2 numbers, or excuse me, 3 numbers, right? Num1 we'll just say is 50, right? I'll do 50, then I'm gonna do 75, and I'm gonna do 100. Okay, so the result of that is 75. That makes perfect sense, right? So you might think that everything is okay, but if you run this again and I enter in values where there is a fractional part, let's see. So we'll just do like 90, 93, and then 94. Okay, and it's saying that the enter is 92. And let me go to my calculator really quick. I don't know what the right answer is. I'm sorry. I can't do all that in my head. So this plus 93 plus 94 is 277 divided by 3. So the answer should be 92.33333 and so on, right? Okay, so it's, wait, what should the answer be? Yeah, 92.3. Okay, so it's missing the fractional part. Okay, unfortunately, I had made everything integers. Okay, but if I wanted to make the average not an integer, I could. I'm just gonna come over here, make that a semicolon, and say, you know what? I'm gonna make this a floating point value so that it can store decimal places, and everything should be okay. Okay, so I'm gonna come back over here, and I'm gonna compile and run, and I'm gonna enter in 90, I'm gonna enter in 93, I'm gonna enter in 94, but I still get the wrong result, okay? Can anybody tell me why I got the wrong result? I made average a float, it should hold a floating point value, right? But unfortunately, everything inside of the equation is an integer, so Java's doing everything as integer math. So it gave me the result as an int. It said, here's the 92. Oh, you want it in a float? Okay, let me add a 0.0 on the end of that. And that was it, okay? So if you actually want this math to occur correctly, we're gonna have to convert one of them, like just one of these variables, to a float. It doesn't matter which one, okay? You can come in here and you can cast maybe this one as a float. I don't know. I mean, that seems like a cool idea, right? Or you can come over here and cast the constant to a float. It doesn't matter which one you do, as long as one of them is a float, Java will convert those, and it will put a float into the equation, which will then give you the correct result when you do your division. You can put it there, or I don't know. I prefer just to put it in the front of the result of the sum of num1, num2, and num3. To me, that just looks cleaner, I guess, because I can see in the very front that I am casting. So now when I come back over here and I compile and run, I enter in 90, I enter in 93 and 94, and I get 92.3333336. Okay, any questions on that? Okay, so that is casting. Like, that's an example of when you would use something like that. Me personally, like, if you wanted to do the average, maybe you could have asked for the numbers in a float, and then you could have avoided having to do any type of casting, right? That could have been one solution to this. Okay, so let me hop back to the lecture, and that's it, casting. Any questions on that? Okay, so the last topic that we're gonna talk about is interactive programs. I did already go over this, but I'm gonna go ahead and read through all the slides. There really isn't a lot. You're gonna have to actually look at the book to get anything more useful out of this. But like everything else, if you wanted to learn anything about any of the Java classes, you can come over here to Google and just type Java. I'm using Java 8. Oops, I meant to type API. I'm saying Java 8 API. Click on this, and then you can look for the class that you want to know more about. Now, I know that the scanner class does live in java.util, so I'm going to look under the different packages. I'm going to look for java.util right here. Click on that, and then these are all the classes in java.util. Right, you see that? Okay, so I'm going to look for scanner. I click on scanner, and then I can sit down and read this and know a lot of great information about the scanner class. There's all the constructors that we can call on it. For this course, we're only going to use the keyboard. We're only going to pass the keyboard to the constructor of the scanner. These methods that you can invoke on the scanner object. So there is a close method. I guess I should be closing my scanner when I'm done. If you're actually reading from a file, that's something that you should do. Otherwise, you're going to have, that program's going to have like that file open. Have you ever like been on your computer and you're trying to access a file or do something in a file and it's saying somebody else has this file open and you're like, what the heck? Is there a ghost in the room? But there isn't. It's just because you have some program that tried to read the file but didn't close that stream, so it still has access to that file. Okay? These are all the methods you can call. I know it's a lot. I'm not going to make you memorize any of them. The ones that you do have to know are the ones that the book talks about. If you look in the book, it gives you like a nice little subset of what you should know. There's the next line, there's next int, there's next float, next double, right? And all those methods give you the primitive data type of what you're asking for from the user. Okay, So let me just hop into this section really quick. All right, so interactive programs. So programs generally need input on which to operate. The scanner class provides convenient methods for reading input values of various types. A scanner object can be set up to read input from various sources, including the user typing values on the keyboard. The keyboard input is represented by system.in object. The following line creates a scanner object and reads from the keyboard. So scanner scan is equal to new scanner and then system in. Okay, so let me just kind of go over this really quick. So just like a variable, we have to specify the data type. So the type of data this variable is holding is a scanner object. So we put scanner, and then this is the identifier. It's just habit to write scan. You can write it whatever you want, like you can name it whatever you want, as long as it's a valid Java identifier, right? Valid Java identifier means numbers, digits, underscore, dollar sign. It can't start with a number, can't be reserved word, that type of thing, okay? And this is what we call a constructor. We'll talk more about constructors in chapter 3, and we're gonna talk about them a whole lot in chapter 4. So a constructor is a special method that sets up your object before it's used, right? So the new tells Java, so the new and then the constructor tells Java that you want to create a new scanner object. You're going to put it into memory. It's going to invoke this constructor. Whatever the constructor does inside of it, it's going to run all those statements, okay? And then you'll be able to use it after that line. System in is us saying read the keyboard. You can actually use the scanner class to read files or even a string if you wanted to. It's actually pretty cool. So here it's telling you the new operator creates the scanner object. Once created, the scanner object can be used to invoke various input methods such as scan.nextLine. The scanner class is part of the java.util class library and must be imported into the program to be used. The next line method reads all of the input until the end of line is found. See echo.java. The details of object creation and class libraries are discussed further in chapter 3. So here's echo.java. You can read that if you want. I'm going to just do my own example of this. Input tokens. Okay, this is actually kind of an important thing. Okay, so an input token is essentially just a value that gets parsed out of whatever it is you're reading, right? In this case, the keyboard. So a token would be whatever our delimiter says is a token. So by default, the delimiter for a scanner is a space, right? So white space. So a token is basically just an entry of that value, right? I have to just show you something really quick. All right, I'm not gonna actually type real code here. So just say if our scanner is reading this line, this is a test, right? That's what somebody typed into the keyboard. So this is one token, is one token, A is one token, and test is one token. Okay, and the reason why is because our delimiter is white space, so it's actually breaking this up into 4 tokens that we can read out of our scanner object. Okay, so that is kind of an example of what they mean by token. I know they're just throwing it out there, and you're just thinking about Chuck E. Cheese or something. Okay, so unless specified otherwise, white space is used to separate the elements called tokens of the input. White space includes space characters, tabs, new line characters. New line characters. The next method of the scanner class reads the next input token and returns it as a string. That's the next method. Methods such as next int and next double read data of particular types. Okay, so one thing to note here is a token scan doesn't actually pull out the next line character or end of line character. And I'm going to show you an example of that. I know one of the students actually came to me before class and he found an issue with the scanner reading data from the scanner where he went from a next line to a token scan to a next line. And what happened was the token scan, when he asked for the next int, it didn't take that end of line character that was entered. So then when the next line came along to read what it wanted to read, it just saw like a blank line. It basically took that end of line character. All right, and they give you an example, and then that's it. Okay, so let me just do a few examples for the next 10, 15 minutes so that we can wrap our minds around this a little better. So I'm going to go ahead and create a new file. I'm going to call this one scanner. Okay, scanner demo 1 is the very first demo I showed you. So I'm going to say scanner demo 2.java and save it. I wish there was a default on this. Why is it always saying .text? It's so annoying. All right, I'm going to copy this. Come on. Gotcha. All right. Control C, save. All right, so actually the first thing I need to do is import java.util.scanner. Okay, and I'm gonna say public class, the name of my class, open, close, curly braces, then public static void main string array, string array arguments. Okay, so I'm going to create what we call an object reference variable, right? So all the variables we were creating before were variables to primitive data types, but we can also create a variable that points to an object. The scanner is an object, so I got to specify the data type, which is scanner, and then I'm going to give it a name. I always use scan or my scan, but I'm just going to say, like, just to change things up, I'm going to just say taco, just to show you that it doesn't have to be scanned every single time. Okay, and then I'm going to instantiate this object by saying new, and then calling the constructor. And then I'm going to pass into the constructor what I want to read. And what I want to read is the keyboard, which is system.in. Okay, so what I'm going to do next is I'm going to demo like a bunch of things like just right here. Okay, so I'm going to say int num1. Actually, let's not do int. How about let's do double. Oh yeah, that could be interesting. Double, we'll say like num1, num2, num3. Okay, and instead of writing all this out, I'm gonna be super lazy with this. I'm gonna hop over to my casting example. I'm just gonna copy what I did here. Control C, paste it in there, and I'm prompting him enter num1, enter num2. The only difference now though is instead of doing next int, I'm gonna have to do next double. Next double is what we call a token scan. So that just means that if you enter in a line, it's not going to read the entire line. It's going to read the very first token of that line. Okay, and I'll show you what I mean here in a minute. And then I'm going to print out the values. Dang it, print out these values. Okay, I'm just going to copy what I did over here because I'm super lazy. Copy this, and I'm just going to say the average of. I'm not going to get all into that. I'm just going to say you entered. And then I'll just give him his numbers that he entered. All right. Save that. I'm going to hop over to my console or my command prompt. I'm going to compile. I don't want to compile that one. I want to compile scanner demo 2.java. Compiles. Dang it. Oh, I named it taco when I was using scan. Nobody caught me on that one. All right, so taco, save. Okay, and let me compile this. It compiles, that's always a really good sign. So I'm gonna say Java and then scanner demo 2. I'm gonna run it. It's asking me for some tokens, or actually numbers. Remember, it's a token scanner. So I'm gonna say 78.1, 97.7, and then, yeah, that 1000.123. Press enter, it recognized the numbers that I entered, okay? Now I'm gonna run this one more time, but this time I'm gonna just, I don't know, just say like I'm not paying attention and I'm in a rush. So I'm gonna enter all my numbers like 89.1 space, 78.5 space, 56.12345, and then I'm gonna hit enter, and then look at what happened. Okay, so because next double is what we call a token scan, right? The very first taco.next double just only pulled off this 89.1, and then it printed out. Then it it's waiting, it's sitting here waiting for some value. I entered all the values on one line, so then it said, okay, well, I'm looking at the keyboard and I see a token there. I'm gonna grab that double, and then it comes to this line, prints it out, and then it'll sit there and waits for the next token, but the next token's already been entered. So it's like, okay, I got what I need. Let's continue. Gets to this line, prints out num3. Then right here, num3 is waiting for an entry, but the entry was already made. It sees a token there and just takes that value and finishes the output. And says you entered, and then that value. Okay, so you kind of have to be careful with this. You're not reading the entire line. You're actually reading a token from that line. And remember, a token is the white space, the thing separated by white space. So that is what we're actually pulling. Okay. Now let me do another example. I'm just going to say file, save as, and I'm just going to name this scanner demo 3. I'm going to rename it, but the other file will still be on Dropbox. So I'm going to come over here, scanner demo 3, and this time I'm going to ask for strings. So I'm just going to say string, we'll say name and college. I'm going to get rid of num1, num2, and num3. Okay, and I'm going to prompt the user for, say, like enter your name. And I have the next line to read strings, but this time I'm going to use next to read name. And I'm going to use enter your college. I'm going to use next to read college as well. Get rid of this here. And then I'm going to say system.println, and I'm going to say you entered that and this, and I'm just going to delete the rest. All right, perfect. Save that. Come over here to compile. I have to change this to a 3. Dang it, num2's in there still. All right, let me copy that, paste it right there. Save. Anything else? No, I don't see anything. Come back over here, compile, compiles, clear the screen. I'm going to run this. All right, enter your name. I'm going to say, okay, well, he didn't specify my first or my last name. So I'm enter in Michael. Oh, there we go. Press enter. And it just went to the college entry, but it saw that next token there as my last name, and then used the last name as my college, right? And it got super confused, right? So you have to be careful with the token and the line scan. If I did a line scan instead of using next, if I would have used next line, I would have pulled everything up until the end of line instead of just pulling the token. So let me go ahead and compile this. Compile, run. So I just changed it to next line. I'm going to run it. Now I want to enter my name. Right, it took in that entire line as my name, and now when I enter in my college, it took in that entire line as my college. Okay. All right. So there is a problem though when you're going back and forth from a line scan to a token scan. So let's just say I also wanted to know age. So I'm going to come over here and make an int for age. And I'm going to say enter your age, like right in the middle of entering your name and entering your college. So I'm going to say enter your age, okay? I'm going to say age is then equal to taco.nextInt. And I'm going to output right here the age. Oh, I did something wrong. Dang it. What did I do wrong? Why is there string, age, string? Oh, I'll have to close this. Okay. And okay. So I have my name, age, and college now. And I added in an entry for my age. So now when I go ahead over here and compile and run, enter my name. Enter that, my age, 25, believe it or not. And then I hit enter, and then it just it didn't know what to do. It freaked out, and it read in college, but then when I want to go print out college, you can look where college was supposed to be. There was actually no value there. Okay, so what happened was I did a token scan, right? So into your name, I did a line scan. It grabbed everything on that line. Into your age, I entered 25. It didn't grab everything on that line. What did it leave behind? Anybody know? It left behind an end of line character, right? Like whatever characters, like tells Java a new line, okay? It left that behind. So when the next line came around, it saw, oh, there's a line there, but doesn't have anything. It's still a line. It's just an empty blank line. I'm going to take that in as the college. So it took that value in for a college. Now there's several ways to fix this, right? Me personally, like if I already had Java 1, 2, and 3, I would probably just read all my input in as a line and just convert that value to whatever I know the value is supposed to be. But for us, what we can do is if you go from a line scan to, or if you go from a token scan to a line scan, right? You're reading a token and then you want to read a line, then you need to release that end of line character by just saying taco.next line. Okay, and that's going to release that end of line character, and then you can actually sit and wait for the college. So now when I come over here to compile and run, I can enter in my name and then my age and then the college. All right. All right, and then there's all the entry for that, right? It works as I expected. Yes.
Could you take that same, could you apply that same principle to, like, when you did next double?
Yeah. Next int or next double. Like whatever, it doesn't matter. It doesn't matter if this is the next int, as long as it's a token scan, and the very next thing you do is a line scan, then you're gonna have to release that end of line character that's still hanging out. All right, does that make sense? That could be any token scan. There's several token scans. There's the next float, the next double. I think there's even a next short and byte, next int, and then a next. Okay, you need to release all of those if you're gonna go to a next line. Okay, so if you come across this problem, this is the way you fix it. I know some students, they'll try to get tricky and just make that a string, right? They'll say age is a string, and then they'll be able to just do a next line scan for the age. But I mean, to me, that's kind of like, I don't really take out points. I guess maybe I should. I don't know, because I don't really specify what data type to use for age. But you're actually like using a string for a value that you know is going to be an integer, right? And I kind of feel like that's like the wrong approach for a programmer, right? I mean, but a lot of times they just did it that way just because that was the only way they can get it to work, right? Like, but I'm showing you here, if you did something like this, then this is how you would solve it. Another thing you can do is just maybe move the age to the last thing that you asked for, right? And then you don't have to worry about that, right? You do two line scans, enter your name, enter your college, and then the last thing you do is enter your age as an integer. That's another solution to this. All right, any questions on this? Okay, so that is it for chapter 2. Chapter 3 is really fun, but everything is like, from this point, this is where like students who are kind of fuzzy on everything, like they just kind of get overwhelmed and they can't keep up. I did post hours for a tutor, so please go see a tutor. Don't wait till the last minute to do your homework. Chapter 3 homework is going to be super complicated. I don't want to say super complicated, but it's not going to be easy. Chapter 2 homework, I feel, is a little difficult as well. So make sure you start early. But I'm going to go ahead and give you that quiz or lab that I said I was going to give you. So I'm going to hop over to our course and come over here. And make a new quiz/discussion. All right, so this is the very first quiz. I'm going to give you guys a lot of these things throughout the semester, so just be prepared for that. I do want you to get this in by midnight. It's not going to be super complicated. It's going to be like a simple program. Okay, so what I want you to do is write a program that prompts the user for 2 integers. Okay, for 2 integers, and in parentheses, I'm just gonna say like, no, well, I'm not gonna put parentheses, but that makes sense, right? Two integers, right? So you can use an int, then calculate the sum difference. It doesn't matter which number is first on the difference. I'm not really paying attention to that. And product, right? This is one of the, you actually have a question in chapter 2, very similar to this. So sum difference product, and I don't know, what's the result of dividing? Anybody know? Dividend, quotient? Oh, that's right, quotient. Wait, that's spelled wrong. Quotient, right? And quotient, and then in parentheses, I'm going to say include fraction. Okay, so what do you have to do on the quotient if you have to include the fraction? You're going to have to like cast or make that math not integer, right? So keep that in mind. Then calculate all of that and print the results. Okay. Wait, I didn't mean to hit save. So write a program that prompts the user for two integers. I'm going to make that bold, then calculate the sum, difference, product, and quotient, and print the results. All right, pretty straightforward. I don't think that is super complicated. I'm going to save and publish this. I know that there's students who probably procrastinated on like doing their homework and all that, and are like super confused right now. So I'm just going to kind of just type up like what I would do if I was doing this. So. Well, you don't want it to be well, yeah, you want the quotient to be a float, but you want to make sure you actually get the fractional part inside of that. So I'll just like name this. I don't know what to name this. Quiz. Oh, but that violates our coding standard. So I'm just going to do this arithmetic. No, I don't even know how to spell that. How about if I just do mathematics? I know how to spell that. All right, and I'm going to come down to the Java source file. I'm going to save it. Okay, so if I was writing this program, the first thing you're going to need is the scanner class, right? java.util.scanner. And then the next thing I'm going to need to do is declare my class, public class, and whatever you named it, mathematics, open close curly brace, and then your main method, public static void main string array, arguments, open close curly braces, and then the next thing you want to do is make your scanner object, right? Pretty straightforward so far. Okay, so now you got to think about, okay, well, what am I doing? Okay, well, I know I'm going to need two integers for the user's input. So I'm going to say int, and then I'll just say like num1 and num2. Okay, that makes sense. And then you know you're going to need integers for the sum, the diff, and the product. And then you want there to be decimals on the quotient. Okay? But then once you have all your variables all set up, now you're ready to start prompting for data. So I'm gonna write it all out for you, and I'll just put some comments here. So I'm gonna say like ask user for one, store, god dang it, store num1. Okay, pretty simple, right? I mean, how would you do that? Use the scanner class, right? You write a prompt, system out print, enter num1, and then you save num1, right? Ask user for num2, and then store num2, right? Store the value. Okay, and the next thing you need to do is pretty simple. It's just do your calculations. Calculate sum, diff, product, quotient, and then in here I'm going to put like don't forget the fraction part. Okay, and then once you have all those values calculated, then the last thing you do is just print out results. Right? In system out print line, sum is this. System out print line, product is this. Difference is this. Right? Like just print all out. Seems complicated when you think about it because I mean, if you know, like all this is kind of new to you, but if you take things like a step at a time, right? Just one step at a time. Okay, what's the first thing I need to do? Import the scanner. Next thing I need to do, make the class header, make the main method header. Okay, and once you're inside the main method header, how about let's declare all the variables that we're going to use inside of this program? So you have to sit and think about, okay, well, what variables I need? I know I need a num1 and num2 for the input, and I know I need a sum, a diff, a product, and a quotient to hold the result of my calculations. And then I'm also going to use the scanner object, so I'll have to make a scanner object, okay? And then once you've done this, then the rest is just prompting the user, storing data, doing some math, and then just printing out the result.